The last section of this quadratics unit is where you're going to have to identify by the graph and by a table if we have a linear, quadratic, or exponential model. The graphs are really easy because if I'm looking at the graph, my linear graph will always be a line, hence the word line within there. If I'm a quadratic graph, I'm a U shape. If I'm an exponential, I'm more of a spread out curve where you will always have a horizontal asymptote, meaning it won't cross over one of those positions. So the first piece here is that you're just going to find the graphs and then decide which model would best fit it. So here's problem A, and it wants us to plot all those points and then decide which model would fit it. So I went ahead and plotted these. So 1, 3 means I go right 1 up 3. 0, 0 would be at the origin. Negative 3, 3 means I go left 3 up 3. Negative 1 means left 1 down 1. And negative 2, 0 means left 2 and stay right there. So when I got finished, that's a U shape, so that tells me that it has to be quadratic. So then I would do the same thing for the next. Plot all 4 points. So 0, 2, negative 1, 4, 1, 1, 2, 0 and a half. Or sorry, 2 and a half. This is more of a spread out curve with a slight ending towards the end. Notice that it's not crossing this asymptote along that x-axis, so this would be an exponential model. And then the last one, negative 1, negative 2 would be there. 0, negative 1, 1, 0, and 3, 2. That forms a nice straight line, so that would be linear. See if you can do the got it question, so pause the video. So in the got it question, you had 2 that you had to fit the model to. So you have the first one, you should be getting this kind of a shape where it's more of a spread out curve, where it's not crossing that y equals negative 1 asymptote, so that would show you it's an exponential model. And then the last one should be a quadratic form because you have more of a U shape between those 4. Okay, the last piece is from a table, and we've done this a while ago where I asked you if it was linear or exponential. Now we're just adding into it quadratic. So let's recall from where we were when it was linear and exponential. If it was linear, that means that you're going to add the same thing all the way across, so meaning it has a common difference. If it's exponential, it has a common ratio, which means you're going to times by the same thing. So I'm constantly multiplying by the same thing. If it's quadratic, it's neither of those two. So you're not adding, you're not timesing, so it has to be quadratic. So let's take a look to see what that would be. So here's my first problem. I was looking to see if are we adding or are we timesing. So I'm finding a pattern. So I look to see, am I adding from one step to the next? Well, yeah, I can add negative 4 from 9 to get to 5. Does that same thing conclude? So can I add negative 4 to 5 to get to 1? And yes, it does work all the way down. So since I'm adding all the way to the end, my answer would be linear. On the next one, it's asking me, can I add something? So yeah, I could add negative 0.25. So then can I add negative 0.25 here? Doesn't give me negative 1 when I do that. I would be adding actually negative 0.75. So this cannot be linear because I'm not adding the same thing. Then I would ask myself, is it exponential? So can I times by something? Well, 0 times what would be this? Well, anything times 0 has to stay 0, so this could not be exponential either because I can't times to 0 to get anywhere. So this is an example where it's neither adding or multiplying, so it would be quadratic. So see if you can do the last one where you have to make a table. So it's giving you ordered pairs, so I just want to give you a hint here. Since it's giving you ordered pairs, you're going to go ahead and make your own table. So all of the x's, those first numbers will go there, and then all of your y's will go in that second column. So now pause and see if you can find what model fits. Okay, so after looking at those, I hope you can find that you were multiplying by 2 every time. So this would be an example of it being exponential. So today's lesson's pretty simple. From the graphs, straight line linear, U-shaped quadratic, exponential is more of a spread out curve. For the tables, you're adding when it's linear, you're multiplying if it's exponential, and it's quadratic if you can't find either one. All right, go ahead and start your assignment.